Hello dear learners, welcome to the video lectures on subject heat and mass transfer. In present session we are going to discuss the basics and nature of radiation, emissive power and absorptivity, transmittivity, reflection and emission of radiation. We know that according to the different modes of heat transfer, radiation is a mode of heat transfer. Radiation is the energy emitted by a matter in the form of electromagnetic waves, or it is also called as photons. We know that in case of conduction, heat transfer takes place without appreciable movement of the particles, or if the particles or body is in physical contact, heat transfer takes place. In case of convection, there is appreciable movement of the particles, but in case of radiation, energy is emitted in the form of electromagnetic waves. Unlike the conduction and convection, radiation heat transfer does not require the presence of medium. Means for conduction we need the medium, for convection we need the medium, but in case of radiation there is no need of any material medium. It is also possible in vacuum. Example, energy of the sun reaches to earth's surface. We know that the atmosphere is present around the earth's surface, but in between the sun and earth there is a vacuum, but also solar energy comes to earth's surface in the form of electromagnetic waves, or it is also called as photons. All the bodies at a temperature above absolute zero emits the thermal radiation. Means all the body exist in the universe which is having temperature above absolute zero are always emits the thermal radiation. Now let us understand nature of radiation. All types of electromagnetic waves are classified in terms of wavelength and are propagated at a speed of light. Means whatever the different electromagnetic waves are there, like gamma rays, X-rays, ultraviolet rays, infrared waves, microwaves, all are having different wavelength, but their speed is similar to the speed of light, that is 3 into 10 raised to 8 meter per second, as shown in this figure. The distinction between one form of radiation and other form of radiation lies only in its frequency and wavelength, and which is related by this formula C is equal to lambda f, where lambda is the wavelength and f is the frequency of the radiation. The emission of thermal radiation having the range in between 10 raised to minus 7 to 10 raised to minus 4. Here you can observe the range of thermal radiation, but don't get confused over here. In this graph the scale is written in micrometer and here it is written in meter. So in micrometer the range of thermal radiation is in between 10 raised to minus 1 to 10 raised to 2. In this range only we are getting the thermal radiation. Thermal radiation also depends upon nature, temperature, state of the emitting surface. What is the nature of the emitting surface, what is the temperature, and what is the physical state of the emitting surface. However, with the gases, dependency is also upon thickness of the emitting layer and gas pressure. In case of gas, the thermal radiation depends on thickness of the gas layers as well as what is the gas pressure. Now the rate of emission of radiation from a body depends on different factor. Number one is temperature of the surface. If the temperature of the surface is high, the rate of radiation is also high. If the temperature of the surface is less, the thermal radiations are also less. Nature of the surface, we can discuss this factor in detail in next slides, or I will explain over here in short. If the surface is planar or it is more open or more plane, the heat transfer rate is more. If the surface is more complicated or it is curved, then the rate of thermal radiation is less. Next, wavelength and frequency of radiation. What is the wavelength and what is the frequency of radiation? That also directly affects the phenomenon of emission of radiation. Now we are going to discuss some basic important definitions. Total emissive power. The emissive power is defined as total amount of radiation emitted by a body per unit area per unit time. Means how much amount of radiation is emitted by a body is directly related to the area of the body and time. It is expressed in watts per meter square. You can see EB means emissive power of a black body is equal to sigma into 10 raised to 4 watts per meter square. This is Stephen-Boltzmann law. The emissive power of a black body according to the Stephen-Boltzmann law is proportional to the fourth power of its absolute temperature. Means if you want to evaluate the emissive power of a black body, it is directly proportional to the fourth power of its absolute temperature. And we know that it is also related to the area. So we have taken capital A, T raised to 4 is the temperature, and if we are not considering the area, then the unit will be watts per meter square. And what is sigma? It is the Stephen-Boltzmann constant, and its value is obtained through the experiments, that is 5.67 into 10 raised to minus 8 watts per meter square Kelvin raised to 4. This value very easy to remember, 5, 6, 7 and 8. Now what is next definition? Monochromatic or spectral emissive power. Here the emissive power is decided on a fixed frequency. In previous we are worrying about the frequency, previous definition, but here monochromatic means a fixed wavelength. At any given temperature, the amount of radiation emitted per unit wavelength varies at different wavelength. If wavelength changes, emissive power also changes. So it is defined as the rate of energy radiated per unit area of surface per unit wavelength. Wavelength is also kept constant. And if you want to evaluate the total emissive power, then we have to take the integration from 0 to infinity for the different wavelength, and its unit will be watts per meter square. Next definition, emission from real surface. We know that emission from a black body is 100%, but in case of real surface, this emission value is less than black body. The emissive power from a real surface is given by E is equal to nu sigma A T raised to 4, where mu is emissivity of a material. Now what is meant by this emissivity? Emissivity is defined as the ability of a surface of a body to radiate the heat. It is also defined as it is the ratio of emissive power of any body to the emissive power of a black body. So this mu can be also evaluated by E divided by EB, where E is the emissive power of a normal body to the emissive power of a black body. The value of this mu varies according to the nature of the body. For a black body, this mu is equal to 1 because it radiates maximum amount of heat. In case of white body, it is 0 because white body does not emit the radiation. And for grey body, means a real body, its value ranges from 0 to 1, and also it varies with the temperature and wavelength. So during problem calculation, we have to calculate the value of mu for any practical body. Now next concept is absorptivity, reflectivity and transmissivity. Let us understand this phenomenon with respect to this diagram. When a incident radiation G falls on a body, it is also called as irradiation. Let us consider that a radiation is falling on this body. The three chances may occur, that is, either it get reflected back. Whenever the radiations are falling on a body, it may get reflected, which is represented by GR. Some part get transmitted through this body, which is represented by GT, and some part get absorbed inside the body, which is represented by GA. It also depends on the nature of a body. Means whenever the radiations are falling, either it get reflected, either it get absorbed, or it may get transmitted. Then according to the conservation of energy principle, total amount of incident radiation may be divided into three parts: absorbed, reflected and transmitted. If we divide it by G on both the sides, here you will get the 1, and this ratio is called as alpha, this ratio is called as rho, and this ratio is called as tau. Alpha is nothing but absorptivity. Whatever the radiations are absorbed by the body are called as absorptivity. Then the fraction of incident radiation reflected is represented by rho, it is called as reflectivity, and the fraction of incident radiation transmitted by the body is known as a transmissivity and is represented by tau. So this concept is very important in case of radiation. Now we will find out the values of alpha, rho and tau for different bodies, and we know that the relation alpha plus rho plus tau is equal to 1. For a black body, we know that black body always absorbs all kind of radiation incident on a body. It does not reflect or does not transmit. So black body is having alpha is equal to 1 because this rho is equal to 0, tau is equal to 0, so alpha is equal to 1. In case of a opaque body, we know that opaque body is the body which does not transmit anything. So for opaque body, tau is equal to 0. So if you put tau is equal to 0, then we get alpha plus rho is equal to 1. So for a opaque body, if tau is equal to 0, alpha plus rho is equal to 1. And for a white body, we know that the white body does not absorb any radiation or does not reflect, does not transmit any kind of radiation. So in case of a white body, alpha is equal to 0, tau is equal to 0, so we get rho is equal to 1. That is, a white body always reflect the radiations. Now let us understand the concept of a black body. We know that black body is the body which absorbs all the radiation incidence on it. So its alpha is 1, rho is 0 and tau is equal to 0. But practically such body does not exist. This is just a conceptual body. In practice, grey body may exist. But for research purpose, a black body having the following property. It absorbs all the radiations falling on it. You can see this experimental body. If radiations is falling on a body, it get reflected inside only, and whole radiations are absorbed after few reflections. It absorbs all the radiations incidents on it. It does not transmit or does not reflect any kind of radiation. Second, it emits maximum amount of thermal radiation at all wavelength at specified temperature. As it absorbs all the radiation, its emissive power is also more, so it having the more emission of radiation. And last, it is a diffuse emitter, that is, radiation emitted by a black body is independent of the direction. Black body may radiate the thermal radiation in all the directions. Thank you.